Embark on a journey through the mathematical landscape where every choice and every arrangement opens a new door of possibilities. Welcome to a world where order and selection are the pillars of understanding complex patterns. Welcome to our comprehensive guide on permutations and combinations. Whether it's the order of players in a team or the selection of letters to form a word, these concepts are the heartbeat of strategic decision making. Join us as we weave together the threads of these powerful mathematical tools to unveil the tapestry of possibilities. Get ready to unlock the full spectrum of sequencing and choosing, where every number tells a story and every story begins with a single decision.
Hi, this is Amit here, and today we are going to discuss probability. Probability is the topic which is very important from business analytics perspective. So let's start with an example. Let's experiment with the order of Indian batsmen. So the Indian team is thinking of experimenting with their top order, and we have four choices to select from, and the four choices are Shikhar Dhawan, Rohit Sharma, Virat Kohli and KL Rahul. We have to see that in how many ways we can order these batsmen in the field to bat so that we can get maximum runs. So what are the different ways to do this? In how many ways we can order this? So there are 24 possibilities in total. You can see that we can have 24 different possibilities in which the batsman can play. They can be Sharma, Kohli, Dhawan or Rahul, or they can be Kohli, Rahul, Dhawan and Sharma and so on. So all these possibilities are listed here in which they can play. Now if we experiment with this, you can say, does the order matters here? Yes, the order matters, because if one player plays after the other player, there may be some pressure on the field if one player does not do well on the field. So in how many combination we can see that it can happen. So if order matters, this is permutation case, and a total number of possible arrangements will be 24, which is 4 into 2 into 2 into 1, and this is called permutation. Now a permutation can be calculated with a formula which is n factorial, and n factorial is nothing but n multiplied by n minus 1 multiplied by n minus 2 till 1. So if the order matters, it is permutation, and this is without repetition. So what is without repetition? When the odd players are playing, once a player is out, they cannot come again onto the field. So once we have experiment with one player, then the next player will come and so on. So if there is no repetition, the formula for permutation would be always n factorial, which is n into n minus 1 into n minus 2 till 1. So in the previous example, we have seen that we have four players and we have to select all four players for the order. So how many possibilities we have? We have 24 possibilities. But what if there are four players and we have to take two players? So how many possibilities will be there? In that case, the number of possibility reduces, and the possibilities are 12. As you can see on the screen, there are 12 possibilities. So you can see Dhawan can play and then Sharma can play, or Dhawan can play, after that Kohli can play, and so on. So there are total 12 possibilities in which they can play. So permutation in this case would be n factorial divided by n minus r factorial. Let's not think that how this formula is right, but intuitively see that how this can be used. So in this case, we had four options of players and we have to select only two players. Okay, so the number of possibilities in this case is 4 factorial divided by 4 minus 2 factorial, and hence it becomes 12.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by Upgrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
In previous example, we have seen that we had four batsmen and we have to select 4 or 2. Now, but does order always matters? Sometimes yes, but sometimes no as well. So suppose there is a case where you have to select 3 bowlers out of 4 bowlers while choosing a cricket team which is going to a tour and they store it somewhere else, maybe in India, maybe outside. Now, how many possibilities are there in which you will choose these ballers? So there are 4 ballers and we have to choose 3 out of them for the next match. So does the order matters here? No, it doesn't really matter. Which 3 you choose, they are going to be part of the team and they are going to play. So the order really does not matter. So if I have to see the number of options and possibilities, how many possibilities do I have? I have 4 possibilities in which I can choose them. I can choose with Kumar Bumrah Yadav and Kumar Yadav Chahal, Bumrah Yadav Chahal and Kumar Bumrah or Chahal. So we can take any of these combinations, right? So you see the order really does not matter here, and when the order does not matter, it is called combinations. Now how do we see the combination? So the number of possible ways to select is 4, and this is combination, and this is given by a formula called n factorial divided by n minus r into r factorial. Now let's not go into the derivation of this formula, let's use it because it is more important to understand the intuitive understanding of it, that how do we get the results of a combination. So if I take the same example, I have 4 options available, 4 ballers available with me, out of which I have to choose 3 ballers, then it will be 4 factorial divided by 4 minus 3 into 3 factorial. So the total answer would be 4. So in this case, the number of options that I have, the combinations that I have, I had 4 only. Now if we compare permutation with combination, you will see in the table, then when order matters, and if I have an option of selecting 1, 2, 3 as a number, I have 6 options here that in the left side of the table you can easily notice. But if I have to choose only 3 and order does not matter, that's combination. I have only 1 option available and that's enough for me. So specifically you can see that when the order matters, the number of choices are more, and when order does not matter, then the number of choices are less.
As our exploration of permutation and combinations come to an end, remember that the journey through mathematics is endless and filled with continuous discovery. Today you have navigated the scenarios where every arrangement has significance and every combination unlocks a new potential. Carry these concepts as keys that unlock endless mysteries in data, probability, and real-world scenarios. Don't let the journey end here. There's so much more to explore and understand. Subscribe, dive into our series for more insights, and join a community eager to decipher the language of mathematics. Together, we will continue to uncover the wonders of arranging and selecting in numbers and beyond.